Hello guys, welcome to lesson 2 of the circle geometry mathematics class. So if you are this upcoming WAEC JAM examination, examination on any kind of exam, you're about to write JAM there, you're able to write mathematics there. So this class is for you. So this is lesson 2. So I remain your guy, Andrew, the founder of Makosh. So I think by now you should have your pen with you. I am let's say material and let's say not material, so you can just jot it down at the end of this class. So don't forget to share with your friends. Okay, don't forget to share with your friends or refer us with your friends so they can have the benefit of this class. So let's see what we have are the first theorems. We're going to be diving into the first theorem. So let me take my pen here. The first theorem I have here is this. Now this first theorem states that a straight line which is drawn for the center of from the center of a circle. So it's supposed to be in a circle there. So bisect a chord which is at right angle triangle. Okay, which is at right angle triangle to the chord. So if we have a circle and we have this the center of a circle, this is the center of a circle, we have a chord. So here to this place we have a chord. I've explained what I mean by chord. A chord is anyone the straight line that touches any two parts of a circumference is a chord. So we have a chord here. So if we have a straight line to bisect this chord from the center of this circle, from this place to this place, we have a diagonal like this that bisects this center of a chord here. Okay, is as a right angle to the chord. So this place will give us a right angle triangle, while this will give us a right angle triangle. You know that the angle here is what right angle triangle is 90 degree. So this are also a 90 degree. So this chord, if I say this point here is point A and I say this point here is point B, okay, and this point here is point O at the center, let's say it's the point O. So you know that this chord there, line A to B is a chord, and we have from this way, so I can just see what a line that I draw for the center of the circle to bisect this one, to bisect what a chord. We will divide the chord into two equal parts. So let me say this place is C. Let me say this point at the point of intersect here, let's say is C. This one is known as L, is C. Let's say is C. Now that means that this line here, this C, I've divided into this line AB into two equal parts, because the line that's drawn for the center of the circle, it bisects this chord, it divides the line into two equal parts. And that means that this line here, okay, is equal to this line here. For CD is equal to what AC. From AC is equal to what CB. They are equal. Now, if you know that a radius for the center of the circle, a line like that for the center of the circle to any part of the circumference, for this way to this place down, it gives us as a radius. Also from this way to this place, what it gives us what as a radius. Here we have radius here, we have radius here. I get down. So this is the height of this bisector. I get down. Now if we're given a question that looks like this, if you like to solve it now, if this angle here, this angle is given at this place, what you just have to do next, what you just have to do here, you know that this part here and this part here, they are equal. This the radius is the radius. You can also use isosceles triangle to solve it. You know, isosceles triangle are they have two sides equal. This side there and this side there are equal. But if the question was given just one side of it, and we're told to find what the height of it, or you're told to find what any of this angle here, you will use because this will give a right angle triangle. And if we're told to find any side of right angle triangle, you use the Pythagoras theorems. So that is all about these theorems 1. More further, I'll be explaining how to do the calculation on these theorems. When you have to identify a question it belongs to these theorems, I will explain to you when we move to the example of issues or theorems. I get down. So let's move to the theorem 2. In the theorem 2, the truth is that equal chord of a circle are equidistant from the center of the circle. So let's say that this is the center of a circle. Let me explain that. This is the center of the circle. So we have a chord. This is one chord, okay, and also it touches this point here. Let's say this point here, and this point here is a chord. Let's say this point A to B is a chord there, and we also have another chord there. Also have on that chord there. So this point here is point C, and this point here to be point D. Okay, now this equal chord of a circle is equidistant from the center. So here they are equidistant from this place, okay, from this place from this place to this way, if you have a bisector from this point here to this point, okay, and also it is also the same distance from this point to this point. So if I say this point here is point S at the point of intersect here, and I say this point here is point Y, so the distance from this place, let's say this point is point O at the center, the distance from this place 0 to Y is the same thing as distance from this S to 0 here. They are equidistant. They are equal in distance. They have the same equal in distance. So the angle here, if I have a radius from this place to this place, as I explained in the previous one, we have for a line I draw for the center of the circle to any point of the circle, when this will give us a radius. Okay, then. So this one to be what? A radius. So this one will give us 90 degrees. That is what we stated at the first theorem. And this point here will give us 90 degrees because it give us a right angle triangle. I get now. So a triangle AOY, the triangle AOY is the same thing. If also you draw a triangle from this place, draw a line from the center of the circle to the point of what, to any point of this place, that is point D here. This one I write as C. Okay, so from this place also, this point here, this also give us 90 degrees because we have given this is also a right angle triangle which was 90 degrees. So the triangle AOC and the triangle AOC, the triangle AOY, it's also the same thing. The triangle COS, they are the same thing. Okay, the angle we have here is the same thing angle we have here. So let's say that we have another radius of the angle here from this point to this point, and also from this point to this point. Okay, so this line here, the angle we have here, okay, is equal to the angle we have here. Take note of that. The angle we have here is equal to the angle we have here. Just take note of that. If you're dealing with this a kind of question like this, that is how you should remember it. The angle here is equal to this angle here, and also the angle we have, this triangle we have here, is equal to this triangle we have here. So you should know that something here, this is a radius and this is a radius, mean that the side here and the side there, they are equal. This place and also this place also are equal to each other, and also this place and this place are also they equal to each other. You understand? So I will explain more further when you are treating more example under this theorem 2. I have a lot of questions to treat under this circle geometry, and I'll be refer you back to the theorems when we go to live or when we go to the example class. I will explain. I'll be refer you back to the theorems too. It is something for you for better understanding. So let's move to theorem 3. So let's move to the theorem 3. I have you as theorem 3. So this is theorem 3. Let's take this one is theorem 3. Okay, now the theorem 3 says that the angle which the arc of a circle suspend at the center is twice the angle at the same arc suspended at the circumference. I get down. Let me read it again. The angle which an arc of a circle sustained at the center is twice the angle, the same arc sustained at the circumference. Now, what does it mean by this? There's some textbook will say that the angle at the center is twice the angle at the circumference. Let me quickly explain what this English means in our circle. Now, let's say that this is the center of the circle. Let's say this is the center of the circle. Now, if you have an arc, okay, let's say for this point here, for this point to this point is an arc. Okay, from this point to this point is an arc. You know, for let's say this, our arc A to B is an arc. For if you look at the distance for here, this place is an arc. What I mean by arc, I've explained the meaning of arc in our previous, that is our lesson 1. So if you missed lesson 1, I'll drop the link in the description below so you can check it, or I'll drop the link in the description below or in the comment section for you to check. That's what I mean by arc. An arc is any point of what of the circumference. Now, let's say that if you have an arc that sustained was the center, okay, the center of the circle, we have from this way to this way, we give us a radius. Here to this place that sustained this arc. Okay, the angle at this arc that formed by this arc, from the angle we have here, let's say the angle here is what is S. Okay, the angle we have here is S. Now it will be the twice the angle it will be twice this angle here. It will be twice the angle that will be formed by this word, by the same work. Let me explain it again. It's twice the angle. It's twice the angle, the same arc sustained at the circumference. For the same arc, let's say that it make on another angle from this part. Okay, this one also cause it. They meet at this part and they form the angle. So let's say the angle here is angle what? S. I mean, let's say the angle is angle S. Now the angle at this center here. Okay, the angle at this center here that sustain this arc is twice the angle at this circumference here. That will be true of this. Let me take one out. It is twice the angle of what? Or twice the angle of this. And if we are given this angle here, if this angle is given here, and this angle at the center here, and we try to find the angle that have the same as the circumference, it will be half. The angle at this circumference here is the half of the angle at the center here. I get now. Take note of that. The angle of this was circumference. If I try to find the angle of this circumference here, it will be half of this angle at this center. And if I try to find the angle, I mean the circumference is given, and I try to find the angle at the center here, something looks like this. I have an angle at the center here. It will be twice of the angle that located at was formed by this circumference. Now, for example, now they may give you another circle. Let me give you because the student used to ask this question. Let me do another circle. Let's say that we have another circle like this. Let me break down there. I have a circle like this. So in this circle, let's say this is the point of, let's say this is the middle point at the center of the circle. So we have an arc. For the first, you look at the point here. We have look at it. You observe the triangle where the way they draw it. So let me. I think there's no space there. So let's look at the way they draw it here. Even remember, we are this place is the point of arc. There's B, and this is what is A. That is A one is A. The line from this way to this way is an arc because it touches what into point of what of the circumference is an arc. Now, if the same arc, okay, if the same arc form another angle for this space or this place, okay, there's a for another go to this place of the same thing. So the angle here is twice the angle of this circumference. Okay, it's twice the angle of this circumference. Again, now it's twice the angle of this circumference. Sometimes the diagram may not be like this, it may be like this. Just know that what since they start from the same arc, the same point, so that means that the angle here is twice the same angle at the center here, and to get the angle at the circumference here is to be twice the angle, or it to be half of the angle of this center. I get that now. So let's move over. This we get this more. If we get this more, if we get if you're solving more example, you'll be learning how to apply this law, apply these rules in more example. Don't worry if you don't get this now. If you understand it now, that's fine. If you don't understand it that deeply, okay. But I'll be refer you back to this theorem when we are treating more example on this particular theorems of this circuit geometry. So let's move to the next one. Let's go to the next one where we're discussing that will be theorem 4. That will be theorem 4. So the theorem 4 says that the angle in a semicircle is always 90 degrees. So let's say that what do you mean by semicircle? Semicircle is the half of the what? Half of a circle. So in a semicircle, you have a line here that draw for the center of the circle. This will give us a diameter. Okay, a straight line that draw for the center of that touches at any point or any 2 points of a circumference that pass through the center of the circle is a radius. I've explained that. Is a diameter rather. It's a diameter. I've explained that in the previous class. Now, if you see it now, it divides the circle into 2 equal parts. So this place and this place are the same. You know the way I draw it, but semicircle is half of what? Of a circle. Now the angle that form in a semicircle is always equal to 90 degrees. So if they have the angle that form for this part here is formed from this place, okay, maybe it gives to this and comes back to this point. So the angle that we have here is 90 degree. The angle here is to be 90 degree. Okay, because it lies on semicircle, that will give us a right angle triangle. I get now. The angle that lies on what? On the semicircle, it is always equal to what? 90 degree. I get now. Now let's move to the next one. Do you understand this one more when we are solving example on that? So let's move to the next one. That will be times 5. This one reverses that. Take note of this. The angle in the same segment of a circle are equal. Angle in the same segment of a circle are equal. Now let me explain that. So this is the center of the circle. Okay, let's say we have a chord. You know, now when I explain the segment, as a segment is the region, it's a region is a space. Okay, it's a space between a chord and the circumference. That is what a segment. The space we have here, okay, the space we have here from this place to this place is a segment. Okay, and also if we have this one, this is we have a segment here. Also we have a segment here. This is a minor segment, this is a major segment. Now from the angle of the same segment, so the angle that form that from this part, it goes for this place. The segment of this major segment it starts from this place and ends at this place. For the major segment, it starts from this place and ends at this place. For the major segment, it starts from this place and ends at this place. So the angle that still lies under of this segment, they must also be equal. If we have the question said that they start from the same place here, if you have the angle that comes to this place, it comes back to the center, and also have the one that also goes for this place. Okay, and since they still lies from the same angle, since they still lies from the same segments, since they see in the same segments, if you have another one like this, if you have another one like this, it's like come back, and also have another one like this. Okay, also have another one like this, that's a come back here. Okay, the angle here is equal to the angle here, are also equal to the angle here, also equal to the what angle here, because the lies what on the same segments. But immediately the angle comes down here, okay, comes down here, immediately the angle comes down here and draw back to this place. It cannot be the same. It cannot be equal to this one, because this if you draw it down here, it means that the angle is not of the same segment we have here. The angle of this one is to be different from the angle of this same segment here. So that means that the angle we have here, let's say this angle, this is N, this one is C, we have D, we have E, and we have what F. So the angle C is equal to angle D is also equal to angle E, also equal to what angle what F. So because the angle that lies of the same segment, the lies on the same segment, they are always what equal. That's what the difference that the angle in the same segment of a circle are equal. So this angle here, they are equal. I hope that one is well clear. So let's move further. Let's look at the theorem 6. So let me go to theorem 6. Let me take my pen out. So theorem 6 says that the opposite angle of the cyclic collateral are supplementary. Now, how does it supplementary means the same thing as 180, and the sum of this opposite angle here is equal to 180 degree. Now, let's take a look how it is formed mean by cyclic collateral. So it means that if we have let's say this is the center of a circle, this the cyclic collateral, it means that what the 4 faces of the cyclic collateral it must touches what this this circumference. It touches this point, this circle at 4 parts, at 4 points. So let's do the cyclic collateral. I know on that we have a chord like this. This is point 1. It's point 1. It touches at this point. It touches at this point to make it at 4 points. If you have a diagram, okay, that is second point, this third one, and this will be the fourth one. It touches at this point, and when they are being connected together, okay, if we have something like this, it touches at this point, then touches at this point, and also touches at this point, and also touches at this point. So let's say this one is A. Okay, this is the angle A, angle B, angle C, and angle D. Now the fact and this story says that the opposite angle here, this opposite angle here are supplementary, means that the sum of this angle D here and angle B here is equal to 180 degree. Again, is equal to 180 degrees. The sum of this or angle D here and angle B here is equal to 180 degree. Likewise, the sum of this opposite angle here, this angle here and this angle here is also equal to what? 180 degree. So the angle A and angle C, the sum of this angle A and angle C here is equal to 180 degree. And that is cycling collateral. Okay, that is collateral are always equal. So that means that, let me just write it mathematically, the angle DAB, the angle D equal A, this A means that we're talking about this A as angle DAB is plus angle, so DAB is equal, is also what? Plus this one will give us 180 degrees. The sum of this one and this, or the angle A and C here, the angle D, let me say plus the angle D what? CB. The angle CB is equal to 180 degree. Is equal to 180 degree. That is supplementary what? That is supplementary. They are supplementary. Is equal to 180 degree. That is cyclic collateral. Likewise, the angle ADB, the angle ADC rather, the angle ADC, okay, the angle ADC plus the angle ADC, okay, plus the angle ABC, plus the angle ABC is equal to 180. The sum of it will give us was supplementary, which is equal to 180. So when you have a expression like this, you look at the diagram that was being drawn inside the circle. It touches what? Touches the circumference of the circle A at 4 points. The way I draw it is easy to identify. That some they will draw it that is defined equal to it won't be as clear. This just look at the diagram, look at the word they drew inside the circle. See, make sure it touches what the circle at 4 points. When you touch the circle at the 4 points, you just remember that this question is cyclic collateral. Now you apply that the sum of the opposite angle of the cyclic collateral is equal to what? 180 degree. Now let's move to the you get this one more with more example under this. Now let's look at the theorem 7. Now, when one side of the cyclic collateral is extended, the exterior angle formed is equal to the opposite angle. So say that one of the side when it is extended. So let's say that we have our cyclic collateral. Let's just scale this one. Okay, this point here, and I'll make this point here. Okay, and let me draw this one back to this. Okay. So this is point A, the angle A, angle B, and angle C, and angle D. Okay, so when one of it extended, one of it should extend out. Okay, for example, the line that is coming to this place is extend out to this part. I get that. So the angle that form at this point is equal to what? Opposite angle. This is it's called the opposite interior angle. The angle that form at this exterior angle here is equal to the opposite. Like if you look at it now, we have this way. This to be the opposite of this particular question here. This angle here. This is the opposite of this one. The way I draw this shape. That is why it will look somehow. But this is the if you look at it then the angle at this now. This is the exterior angle. This is the exterior angle, and the angle attached to this is the exterior. This is the interior angle. So the opposite of this, the angle we have here, is equal to the angle we have here. So if this angle here is S, the angle here must be equal to what? S. I get down. The angle here, if this angle here is S, the angle of here to be equal to what? Is equal to what? S. So you can write it as mathematically that the angle D is DAB. We have the one DAB. Okay, the angle DAB is equal to, we have the angle is equal to the angle BC. So let me say that the extended angle here to be equal to, let me say is E. Okay, it's extend more to form another lines with this is what? E. So that means that the angle BCE is equal to angle BCE. That is angle what? BC what? E. They are equal. You can state that it is because what? Exterior angle, the exterior angle formed is equal to interior angle. That is circular. When one of the side is extended angle, the angle of this exterior angle is equal to opposite interior what? Angle. It will be equal to this. That is our use of that. So let's move to more. You will understand this when I treat more example on this. So let's move more. Let's study more theorems. The theorem 7, the theorem 8 rather. so that the angle between a target, okay, and a radius is always equal to 90 degree. The angle between a target now and a radius, so this is the center of a circle. What I mean by the target, I've explained a target in our previous class, that is lesson 1. So target is what is a straight line that touches what the circle at one point. So let's say that we have a straight line here. I thought this circle at one point, so this is the point it touches now. So and we have a radius that bisect this particular what called a target. So for the center line of bisector that bisect this what this target, okay, at this target at this one point in. So the angle, say the angle between this way is a radius, and this is part of the intersect to this one, to this tangent line. So we here that this way is a radius. Okay, now they said the angle that form between these targets and this radius is equal to what? Is always 90 degree. Yes, it's 90 what? 90 degree. The angle here is 90 degree. Okay, and if you still have the same thing here, the angle here is equal to what? 90 what degree. Okay, they are 90 degree. That is just it. Hope that one is very clear. I will explain this one more further when we are treating more example on it. So let's move to the next one. Let's move to the next one. That will be theorems 9. Theorems 9. Sorry, the theorems 9. The theorem says that the angle between a tangent from the points outside, the angle of two tangents from the point outside the circle are always equal. Okay, are always equal. So let me analyze this. So if we have let's say that we have two targets. Okay, we have the first target, it's like drawn here, was outside, and also we have another target that was being drawn outside. Okay, that was being drawn outside there. So this is where they meet. So the angle here, so this is the center of the circle. Okay, this is the center of the circle. So it means that's what we have here now. Let's have another line that divided into two that touch any point of the wall, that touch the point of this circle. Okay, so the line here, the line here is equal to this line here, and the angle that form here is also equal to the angle that we have here. You know, from this point here, from this place to the point of the intersect here, that is what we explained in the previous class. This place is 90 degree. Okay, this place is 90 degree for the center. That is what we explain here, because the bisector to the line of this tangent will give us 90 degree, because here is a radius. Okay, the same thing applicable to this. If we have it like this, that bisect it will also give us a radius. This also give a radius. So the angle here is also equal to what? The angle here. I get on. The angle here is also what? Equal to the angle here. So the angle here is also equal to what? To the angle here. So that is what they say what the length of a two tangents from the points outside the circle are equal. So the length of these two tangents, this target here, this is the length, and this length here, they are equal to each other. So let's move further to look at the last theorems. I will go to explain to you, and before we move to the more example, this will be theorem 10. They will still say that the angle between a tangent to a circle and a chord drawn from the point of the contact is equal to the angle in the alternate segments. It's equal to the angle of the 10 segments. So let me say that we have a tangent. This is the point of the tangent. Okay, a chord, see that the angle between a tangent of a circle and a chord and a chord drawn from the point of the contact. So for this, the point of a chord, and so we have a chord. If we draw a chord like this, okay, if you draw a chord like this, also you can also have something that we have a chord that may also be drawing like this. Okay, if you draw a chord like this, a point of contact that will draw from the point of the contact is equal to the angle in the alternate segments. Now, if you have this chord, if you want to work on this chord, okay, this is the segment, this is the minor segment, and this is what the major segment. So the angle we have here, you have this angle for this segment, it will be equal to the angle alternate segments. Okay, it will be equal to the angle at this entire segment. So the angle that lies at this point, it will be equal to this. So let's say that the angle we have this another angle that form like this. Let's break it down. The angle here, this angle to be the angle we have here, it will be equal to the angle we have here. This is the segment, okay, formed by this chord. It will be equal to the what alternate segments. This another segment, this is the minor segment. For here this space is minor segment, and all here is what alternate is under what major segments. I get now. So the angle we have at this word at that form between this chord and this tangent, it will be equal to the angle of the opposite or the alternate what segment, and this is the alternate segment. That's what refer to this minor segment, that is the major segment, and the angle that lies there to be equal to this angle here. So if this angle here is S and the angle here is equal to what is also equal to what S. The same thing applicable to this. If this angle here, the angle here is equal to the angle here is equal to the angle at this place. So if this angle here is Y, the angle here is equal to what Y. That is what alternate segment theorems of circle geometry. So guys, that will be the whole for this. If you have any question, let me know in the comment section. That will be the end of this circle geometry theorems. That will be the end of this circle geometry theorems. So let's meet in the class for example on how to solve question under this or circle geometry using these theorems. Thank you. Don't forget to share with your friend. Let's meet in the next class.